Hi, this is Stelios from the Tesseract Academy, and I'm going to be introducing you to blockchain, some of the core concepts behind, and then we're going to see a brief description of some of the most popular blockchains out there. So the first thing we need to ask is, what is a blockchain? A blockchain is a distributed ledger. So a ledger is pretty much like the books that accountants have. So there are nodes in this network. We're talking about a network, and every node has a copy of that ledger. And this ledger holds all transactions. And the transactions include details, obviously, such as the amount of value exchanged and where this value moved to and from, but also chronological information. So we know exactly what happened when. And it's very important that anyone can verify the validity of this ledger. So this is a very simple but powerful idea, and we'll see why. So it all starts with the problem of double spending. Let's say that you want to create an electronic form of currency. We have Bob and Alice, and Bob wants to give Alice 2 electronic coins. So if these coins were presented as files, then there's nothing to stop Bob from copying these files multiple times and Bob effectively become a millionaire. Distributed ledgers are a way to avoid this kind of problem because they record every transaction. So once Bob sends some coin, some value to Alice, then this transaction is recorded down and it cannot be changed. One of the main issues in blockchains is the way of how the ledger should be verified, how transactions should be verified, and how the nodes should reach consensus and agreement. So the participants in the network must agree on the true state of the ledger. And that's an issue because different nodes might have different versions of the ledger, and this could be either due to technical faults or it might be due to a malicious attacker that is trying to double spend. This problem is related to the Byzantine generals problem, which for two generals it was proven to be unsolvable in 1975. So what's this problem about? We have two generals, which you can see in this picture here, A1 and A2, and they want to attack a common enemy, B. So they need to agree on the time of the attack, because if they don't attack at the same time, then they're going to lose the battle. So they can communicate with each other by sending messengers. However, because B is in the middle, B can capture a messenger and then send another messenger who's going to provide false information to A1 or A2. So the question is, when you have two generals, how can they be 100% certain that yes, the other general sent me a message and told me to attack at this particular time? Well, with two generals, this is unsolvable. Okay, however, Bitcoin solves this, and all blockchains they solve this by using more than two nodes. And shortly, we're gonna see how this happens. Before we move on explaining about Bitcoin and other blockchains, this is a brief history lesson. It really shows the progress that has been done over just a few years. So the original concept around some form of electronic currency was called Hashcash and was created in 1997. However, no one really paid much attention back then. Then we had Bitcoin in 2008, which again, when it was first created, when it was first heard of, it was some kind of obscurity, like people were fascinated by it, some people believed it's the future of money, but it was not as popular as it is now. Bitcoin created many innovations, we'll see some of this later, and then it let other people build basically on top of the technology that it innovated, blockchain. So then after Bitcoin, Ripple came out, Stellar, Neo, IPFS, Ethereum is probably the single most important advancement in the field of blockchain in the last few years. And now we also have Hyperledger, Corda, and in the meantime we also have many other cryptocurrencies. And also distributed ledgers which are not blockchains. Corda is one such case. And again, this is a brief history lesson to show you how fast this area has progressed over the last few years, but it's by no means an exhaustive list of the things that are out there, because there are countless different kinds of blockchains and cryptocurrencies. This graph, you can see a nice summary as to how blockchains can be clustered. On the left hand, the permissionless blockchains, and then we have the permissioned on the right hand side. And as you see, we move from open to closed. So a permissionless network is a network where anyone can join. So if you want to buy Bitcoin, it's very easy to buy and sell. And if you want to become a node in the Bitcoin system, if you want to mine Bitcoins, again, you can do it. It may not necessarily be a very good financial proposition now, but you can do it. Permissioned systems, on the other hand, are systems which are private. These are systems such as Hyperledger Fabric, which usually are created to solve problems in enterprises. and they are just not open for the public. And in the middle, you have systems like Ripple, which are public but are not completely open. And there are different consensus mechanisms that are used. Proof of work, which we're going to explain more about this later, is the earliest consensus mechanism that was devised. And now we also have proof of stake, federated Byzantine agreement, Byzantine fault tolerance, and many other consensus mechanisms. And obviously, some of these consensus mechanisms are affected by whether the blockchain is permissionless or permission. So a question we need to ask is why decentralization? So one of the key components of blockchains and most blockchain projects is some degree of decentralization. So we discussed how Bitcoin solved the problem of double spending for creating an electronic form of currency. However, this problem is also solved by online banking. The thing with Bitcoin is that there's no central authority. There's no central set of nodes that define what's the true state of the ledger. There's a process, there's a protocol that defines this. It's a decentralized protocol. This has been one of the key components of most blockchain projects, decentralization. And if we look into the history of proof, we can see that humanity has been moving towards more and more decentralization over the years. So at the first layer, we have what I call proof in a service. So there is some kind of action that's taken and it's validated by some kind of higher authority, such as voting or a wedding in a church, for example. And this service and the authority, they provide some proof that this deed has happened. Then we move to proof as a service. So now we don't need a big central authority to provide proof of something, and we don't need to take some kind of action, which is we can use some kind of document, or we can go to some company that can do this for us. For example, in countries there are ID cards, so this is published by the state, and then you can use this on demand when you need to prove your identity. Or you can have a proof of physical address as a utility bill. So this utility bill is sent to you for some other reason because you want electricity or water. However, you can just use this kind of service. You can also use it to prove that you live in a particular place, etc. And then we have proof in a consensus, which is what blockchain is proposing. So what blockchain is proposing is that we no longer going to have proof of something, let's say in transaction, because there's some kind of higher authority, or because someone took some action, or because there was some document which was issued and blah, blah, blah. There's a protocol that works in an automated way and ensures that we all agree on the true state of the transactions. So the whole thing behind decentralization is that there's an even greater vision lying behind it. So some people are talking about Web 3.0. And right now we're at Web version 2, and the vision behind Web version 3 is that through these consensus mechanisms, central authorities will be less needed, and the Web version 3 will be more decentralized, better connected at the individual level, at the peer level, and more private and more secure. So this is an example between Web 2 apps and Web 3 decentralized apps. So we can see that in Web 2 we have Chrome, and Web 3 we have Brave, where Brave has issued tokens and can reward content creators for the content they produce. In terms of storage, we have Dropbox and Google Drive in Web 2. In Web 3 we have IPFS, and we're going to talk more about IPFS later on towards the end of this presentation. In terms of social networks, we have obviously Facebook and Twitter, but in Web3, we have things such as Steemit, which have different kinds of tokens, and these tokens can either be used to reward content creators or to invest in the platform. And you realize from these descriptions that the common theme is that users can directly invest in content, they can invest in platforms, and they don't so much depend on a central repository for their data. I mean, that's the main argument behind IPFS. So this is where Web version 3 is taking us. This nice chart shows us a comparison between Web version 2 and Web version 3. Again, you can see how many applications are out there. that try to replicate what's already in version 2 but make it decentralized. I mean, there are just so many services out there, it's impossible for someone to know all of them. So you can see here, for example, that for freelancing, we have VLANs and freelance, but now we're moving to FLANs, which is based on Ethereum. For computation, we're moving to Dfinity, for example, from Amazon, AWS, etc. Again, there are many people that believe in this vision, that the future of web is decentralized, and decentralization lies in blockchain. So now we're going to go through an overview of some of the most important blockchains and cryptocurrencies out there. So the most important one is obviously Bitcoin. The paper was published in around 2009 by an entity called Satoshi Nakamoto. And Satoshi Nakamoto, no one really knows who this entity is. No one really knows whether it's one person or whether it's multiple people, male or female. However, in this paper, which is very nicely written, this entity outlined a series of innovations that allowed the creation of Bitcoin. So Satoshi Nakamoto outlined how a distributed ledger can be created where every node has a ledger replica. And the nodes synchronize periodically by approving blocks of transactions, and they do this through a mechanism called proof of work that ensures that there is consensus in between them. All the information in the ledgers is encrypted, so it's not easy for someone to see who spent what. However, it is easy to verify that the ledger is indeed correct. The proof of work idea was published in 93 and then it was advanced even further in 99. So it's not a new idea. However, Bitcoin was the first project where they used it in this way. And the term blockchain came out of this process, that transactions are aggregated together in blocks and then blocks are verified by the nodes. So one of the key components of proof of work is that it requires lots of electricity, lots of work, hence the name, to verify transactions. However, once the transactions are verified and you found a solution for a new block, it's very easy for other nodes to verify that you're telling the truth. Indeed, yes, you have found a solution for this new block and this block can be added to the chain. So that's the key component, asymmetry, because finding the solution is going to take lots of resources, but verifying the solution is something that can be done even on a laptop. So the main component of proof of work is that because of this asymmetry, it becomes financially irrational for a miner to try and hack the network. Because if someone tries to hack the network, a brute force attack, then they would have to spend basically as much resources as the rest of the network has spent in order to validate all previous blocks and the new block. So it's basically infeasible. I mean, given that there are enough nodes in the network, it's basically infeasible. However, proof of work is not invincible. There's still some issues. For example, there's the issue of a 51% attack. So if someone controls 51% of the network, then they can double spend. So how are they going to do this? They're going to spend money in the public blockchain, and then they're going to verify a private version of the blockchain where the money has not been spent. And there's some kind of majority voting scheme in Bitcoin if there's a class. And if someone controls 51% of the network, then it's easy for them to get their version approved. So this sounds like it's not an issue if you have loads of nodes in a network. However, this attack has been done on some cryptocurrencies. So if nodes, for example, are not that many or are geographically clustered in an area, then this is suspicious. Then this cryptocurrency, which assuming it uses proof of work, is susceptible to this attack. Another issue with proof of work is that it consumes huge amounts of energy, and this is very bad for the environment.